Now we're going back to numbers. Nomenclature was kind of, had very little math in it. We're going to get back to some math. Formula mass. Formula mass is the mass of the formula. So the average mass, pointing at the wrong thing. The average mass of an individual molecule or formula unit. Formula unit's the term we use for ionic compounds. It's also called the molecular mass or the molecular weight, but it's the weight of a molecule, the mass of a molecule, the mass of a formula, all the same idea. You just take the sum of the masses of the atoms in the molecular formula unit and add them all up. So, what's the formula mass of calcium nitrate? Well, first we need the formula, right? What's the formula for calcium nitrate? So let's write it out for those YouTube watchers who aren't getting it, because I know all of you got it down cold, right? What's the charge on calcium ion? 2+. And what's the charge on nitrate ion? It's -1. We have to have the charges before we can write the formula. Otherwise, you're going to get the formula wrong, most likely. Now we put these together. Based on the charges, we need 2 nitrates to balance the charge on 1 calcium. Going for the lowest ratio of ions that will add up together to have a 0 charge overall. We know this is an ionic compound because calcium is a metal. It's not going to be a binary molecular one. There's no prefixes, that's another hint. Now that we have the formula, we can calculate the formula mass. So we look at the formula, and there's 1 calcium atom in this formula unit. And so we find the mass of calcium, 40.078. So we've got 1 times 40.078. What would the unit on that be? AMUs. It's not going to be grams, because 1 calcium atom does not weigh 40 grams. And how many nitrogen atoms are in the formula? 2. And 14.0067. Yeah, I'm going to go with what's on the chart this time, but then in the future I'm going to go with the 4-digit ones I've memorized. How many oxygens? 6. 6 times the mass of oxygen. And then we add them all up together. It's math, but it's not that hard. 40.078 plus 2 times 14.0067 plus 6 times 15.9994 equals, and my calculator shows me 164.0878, and the unit on that is atomic mass units. How many significant figures? We're basically adding, right? So if we thought about taking this number plus that number, we're adding 14.0067 twice and adding this number 6 times. This has 4 decimal places, this has 4, and this has 3 decimal places, so we should stop it here and call that 164.088 atomic mass units. Usually we do not get too hung up on sig figs with formula masses, because usually it's the other measurements that end up limiting the number of significant figures in your answer. But do not round your masses and go, oh, it's 40 plus 2 times 14 plus 6 times 16, and drop off all those digits. Sometimes there'll be enough rounding error that you'll get the answer wrong. That's okay if you're going for a round number, but if you're really trying to calculate something, use all the digits that you have. Now, the periodic table that I give you for an exam has all of the molar masses or the atomic masses on the periodic table rounded to 4 significant figures. And that's just done for convenience. And most of the time, that's not going to limit the number of sig figs in your answer. So go with whatever periodic table you're using and just use what they give you. So from now on, you'll probably see me rounding them all to 4 significant figures because I know a bunch of them, and it saves my neck looking up there. There isn't one in the back of the room. So just to explain what I'm doing with that. So that's formula mass, the mass of a formula. The molar mass is the mass of a mole. Remember our friend the mole? Avogadro's number of molecules. So what's really cool about how they define the mole and the atomic mass unit is that the mass in grams of 1 mole is numerically equivalent to its formula mass. So we just calculated the formula mass of calcium nitrate. Did anybody write it down? What was it? $164.809? I can't hear you guys. You're talking. 088. I think it was 089. Was it 8? Okay, sorry. So atomic mass units. So that's the mass of 1 formula unit of calcium nitrate. And if we change this to grams, it's the mass of a mole of formula units. Isn't that convenient? Very convenient. And it didn't happen by chance. So what's the molar mass of ammonia? What's the formula of ammonia? Remember? NH3. NH4 plus is ammonium, the ion. Okay? NH3 is ammonia, the molecule. So to find the molar mass, we do the same process as finding the formula mass. It's just that the unit's different. So 14.01 plus 3 times 1.008. And we get 17.0, is that 3? I think it comes out to 3/4. Yeah, 17.03 grams. That is equal to 1 mole. So we talked about using mass to count atoms. We can use molar mass to count molecules. So the basic idea here is if you have grams of compound A, you can find the number of moles of compound A using the molar mass, and then you can find the number of molecules using Avogadro's number. Example, nitrogen dioxide is a component of urban smog that forms gases in car exhaust. How many molecules are in 8.92 grams of nitrogen dioxide? Well, this comes down to being a dimensional analysis problem. There's only one number in the problem, 8.92 grams. What's the formula of nitrogen dioxide? NO2, nitrogen dioxide. And they want to know how many molecules of that. So, how do we do that? We need the molar mass. So with the molar mass, we can change grams into moles. And Avogadro's number allows us to convert moles into numbers of molecules. So 8.92 grams NO2 times, we want moles on top, times molecules on top. We'll end up with number of molecules. And then we want to put grams on the bottom, so those will cancel out. And we're going to put moles on the bottom over here, so those cancel out. Number of molecules in a mole, that's Avogadro's number. 6.022 times 10 to the 23rd. That's always the same. But the relationship between moles and grams is the molar mass of the compound, and that's different for every compound. So calculating molar masses is something that needs to become very, very straightforward and easy for you. You just need a calculator, a periodic table, and the formula. So here nitrogen, there's one nitrogen, 14.01, and two oxygens at 1630, that's 44.01. Grams. You can say grams equals 1 mole. That's true. Or you can write this as grams per mole. Same thing. The molar mass is an awesome conversion unit that we use all the time in chemistry. 1 mole is 44.01 grams, not the other way around. I did that wrong, didn't I? 16 times 2 plus 14.01. Yeah, it's 46. 44 is the molar mass of carbon dioxide. Sorry about that. 46. Let's fix this guy. .92 divided by 46.01 times. Yeah, I already screwed up. I need my real calculator. So the real calculator tells me a whole bunch of digits. In this problem, the number they gave us for the mass is limiting the number of significance in the answer, significant figures. And so the fact that we rounded this a little bit is not going to matter. There are times when it matters, but this should have 3 sig figs. And so I'm going to write 1.17 times 10 to the 23rd molecules. Is that a reasonable number? Yeah, it is, because 8.9 grams is not a lot of mass, but it's large enough that you could see, right? Anything that's big enough that you could see is going to have lots and lots and lots of molecules.